Perhaps most significantly, the year without a summer delivered a harsh lesson about humanity's vulnerability to climate fluctuations, a lesson with profound relevance today as we grapple with anthropogenic climate change. The events of 1816 demonstrated how even relatively small changes in average temperatures can produce dramatic disruptions to agriculture, economics, and society at large. When Tambora erupted in 1815, the scientific community lacked the tools to understand its global impact. Meteorology was in its infancy. The connection between volcanic eruptions and climate change wasn't yet established. People could observe the weather anomalies but couldn't explain them. Early hypotheses about the strange weather of 1816 ranged from the scientific to the bizarre. Benjamin Franklin had previously speculated that volcanic eruptions could affect climate, but this theory wasn't widely accepted. It wasn't until the 1880s, after the eruption of Krakatoa in 1883, that scientists began to systematically study the climate effects of volcanic eruptions. A full scientific explanation would require advances in atmospheric chemistry, fluid dynamics, and computer modeling that wouldn't be available until the 20th century. Today, we understand the volcanic winter phenomenon in great detail. Modern climate models can simulate exactly how volcanic aerosols affect global temperature patterns. We know that major eruptions can influence climate for 2 to 3 years before the sulfuric acid particles finally settle out of the stratosphere. We understand the complex feedback mechanisms that amplify the initial cooling effect, such as increased snow cover reflecting more sunlight back into space. What makes Tambora particularly significant in scientific history is its role as a natural experiment in climate forcing, a dramatic demonstration of how atmospheric composition can alter global temperatures. The lessons learned from studying Tambora have directly informed our understanding of other climate-altering mechanisms